Hello everyone, welcome to this lecture of engineering graphics. Today we are going to learn engineering curves or plane curves. So this is the overview of the today's lecture, the conic section. That in that we will see ellipse, then parabola, how to draw the parabola, how to draw the ellipse, then how to draw the hyperbola. So there are some methods to draw the conic section. Let us see. First method is directrix focus method. By this method, we can draw ellipse, we can draw parabola, we can draw hyperbola. Also, ellipse can be drawn by concentric circle method, by rectangle or oblong method, by arc of circle method. Then parabola can be drawn by rectangle or oblong method, or maybe tangent method. Then ellipse hyperbola can be drawn by directrix focus method that already we have discussed. Then conic section, when a right circular cone is cut by a section plane in a different position with respect to axis of cone, the section obtained are called as a conics. Let us consider this figure. When cone is cut by a cutting plane line which is parallel to the base, then you will get the circle. When cone is cut by cutting plane line which is inclined to the axis and cuts all the generators, then you will get the ellipse. When cone is cut by cutting plane line in such a way that cutting plane line is inclined to the axis and parallel to one of the generator, then here you will get the parabola. When cone is cut by cutting plane line which cuts the generator and the base without cutting the axis, then here you will get the hyperbola. So all the conic parts you will get by cutting the cone. So before that, we will see some definition or a definition of eccentricity. What is meant by eccentricity? It is the path generated by a point in a one plane in a such a way that the ratio of its distance from fixed point, that is focus, to its distance from fixed line, that is directrix, remains constant. So that ratio is called as a eccentricity. The ratio is called as eccentricity. If the ratio E, that is eccentricity, is less than 1, so it is a ellipse. If the ratio E is equal to 1, then it is a parabola. And if ratio is greater than 1, then it is a hyperbola. The line at right angle to the directrix and passing through its focus is called as axis. Then point at which the conic curve cuts its axis is called as a vertex. Where the conic curve cuts the axis, that particular point is called as a vertex. So this is all about some terms, definitions of the terms. So let us consider this figure. This is an ellipse where you can see here that is the ratio of P1 F1 by Q1 P1 is less than 1 for the ellipse. P1 F1 divided by Q1 P1. So the ratio of that two terms is less than 1. That is, eccentricity of the ellipse is always less than 1. Then let us consider the second figure. This is a parabola. If you see the ratio of P2 to F1, the ratio of P1 F1, line P1 F1 and line P2 Q2. So that ratio is exactly equal to 1. So it is a parabola. The next one is a hyperbola. If you see here, the ratio of P3 F1 and P3 Q3 is a greater than 1. So it is a hyperbola. So for the hyperbola, eccentricity is always greater than 1. So all the figures you can see here, for the ellipse it is a less than 1, that is eccentricity. For parabola it is exactly equal to 1, and for hyperbola it is greater than 1. So now we can learn how to draw an ellipse by using directrix focus method. So let us consider this example. To construct an ellipse when the distance of the focus from the directrix is equal to 60 mm and eccentricity is a 2 by 3 by using directrix focus method. So what they have given in the problem, that is a distance between directrix and focus, that is which is equal to 60 mm and eccentricity is 2 by 3. So let us see how to draw the ellipse by directrix focus method. First of all, should have to draw a vertical line which represent the directrix at any point. You should have to draw the vertical line which represent the directrix at any point, and let us consider that point as a O. A right angle, draw an axis O2, and the name of the axis is O2. So this horizontal line is called as an axis and that vertical line is called as a directrix. By taking point away from that directrix is equal to 60 mm, let us consider this point as a F, which is focus. Then next point is, now you should have to divide this OF into 5 equal parts, because we have a eccentricity that is 2 by 3. So 2 plus 3 is equal to 5. That's why you should have to divide this line into 5 equal parts in a such a way that V1, that is vertex point, should be away from focus, and that is directrix. So that distance from directrix to vertex should be equal to 36 and distance from vertex to focus is equal to 24. So that ratio would be equal to 2 by 3, that is eccentricity should be equal to 2 by 3. By taking this into consideration, you should have to take the point V1, that is 2 parts away from the focus. You will get the V1, that is vertex. From that point the curve is passing. Through V, draw a perpendicular line, that is V1 dash, to the axis, which is equal to V1 F. First of all, draw the vertical line. One another method is there. You can draw the vertical line over there, and by using curve, you can draw the one curve from F to this line. So you will get the same distance over here. Then draw a line from O point to the V point and extend it. Then mark points on the axis, that is 1, 2, 3, 4, 5 likewise, and give the names, that is 1 dash, F dash, 2 dash, 3 dash, 4 dash, 5 dash. Likewise you can give the names to that particular points. After that, take a distance in your compass from 1 to 1 dash, keep on F and mark one point on 1 dash. Look at here, take a distance equal to 1 to 1 dash, keep a point on F and mark on a 1 dash line on a both side of the axis. So you will get the 2 points. One point is here, another point is here. So you will get the 2 points, give the names to that particular points. Same way, you can take the distance from 2 to 2 dash, keep distance, keep a point on F, mark point on 2 dash on a both side of the axis. Similarly, you can mark all the points over here like F dash, 2 dash, keep a distance point on a F, mark on a 2 dash, 3 dash, keep a point on a F, mark on a 3 dash line on a both side of the axis. So likewise, you can mark all the points of that lines and give the names to that all points. And then after that, you will get the, by joining all the points, you will get the ellipse. So we have learned today how to draw ellipse by directrix and focus method. Thank you.